Imagine just stepping outside tonight. You look up, you see the moon glowing in the dark, right?
Yeah, a classic night sky.
Exactly. And maybe pull your jacket a little tighter against the chill of a winter breeze. And off in the distance, you hear the ocean tide rolling in. It's just a perfectly normal, beautiful night on Earth.
Right, something you wouldn't even think twice about.
But what if I told you that when the dinosaurs were walking around, absolutely none of those things existed? Like no moon, no winter, no
I
tides.
mean, it immediately sounds like science fiction, doesn't it?
Totally.
We're so used to thinking of our planet as this incredibly ancient, completely static stage.
Hmm.
Like the play of evolution just sort of happens to unfold on it.
Right, like the set pieces were always just there.
Exactly. We assume the rugged mountains, the changing seasons, the moon and the sky, that they've just always been around.
Well, today's deep dive into the source material explores this really radical alternative geological model that just flips that entire script upside down.
It really does.
It's called the Small Bang Theory, or SBT, and it was developed by an independent thinker named Arndt Meyer. And what's really wild is that he pieced this massive planetary puzzle together through like thousands of hours of research, but also through this intense ongoing dialogue with an AI assistant.
Yeah, an AI named DeepSeek. It's a really fascinating modern approach to the whole scientific method.
It is. And, our mission today is to take this incredibly complex paradigm-shifting theory and just break it down. We want to explain the history of our planet so simply that, well, honestly, so a teenager could grasp it.
Right, using everyday examples.
Mm-hmm.
Because at its core, this theory argues that the Earth didn't just, slowly shift and change over billions of years.
And it argues something way more dramatic.
Yeah, it argues that the Earth turned into a giant planetary pressure cooker that literally, and I mean literally, popped.
Okay, so let's unpack this, because before we can talk about a planet exploding, we have to understand how this bomb was built, right? Like, why did the Earth become a sealed trap in the first place?
So to see that, we have to rewind the clock way back to about 4.6 billion years ago.
Okay, setting the scene.
The Earth is just this chaotic, molten ball of liquid fire floating in space. And the physics here are actually quite intuitive. Think about what happens when you melt different materials together in a giant cauldron.
Right, gravity takes over.
Exactly. The heaviest elements, like iron and dense metals, they naturally sink deep down to the center. That forms the Earth's core. Meanwhile, the lighter rocky materials, they sort of float up to the surface.
The sources compare it to the layer of slag or scum that floats on top of liquid iron in a blast furnace.
That's a perfect analogy. So you have this lighter molten rock floating on the outside, and it's exposed to the freezing vacuum of space. So naturally, it starts to cool down.
Makes sense.
And as it cools, it hardens into a solid granite crust.
But wait, how thick was this crust? Because when I think of the ground, I just think of it going down forever.
Well, according to the sources, this solid granite crust eventually reached a thickness of between 20 and 60 kilometers.
Okay, 60 kilometers of solid rock sounds pretty impenetrable to me.
To a human, absolutely.
Yeah.
But on the scale of an entire planet, it is remarkably thin. It's proportionally, it's just like the thin skin on an apple.
Oh, wow. Just a thin little skin holding all that in.
Right. And for billions of years, this skin wasn't completely solid. There were massive cracks and these huge volcanic vents.
Especially around the equator, right?
Yeah, mostly at the equator. And intense heat and gases from the molten interior were just constantly escaping into the sky through these vents.
But then we hit this, critical turning point. Because the sources point to roughly 541 million years ago. And Meyer's theory suggests that by this date, the Earth had cooled just enough that those final massive volcanic vents at the equator sealed completely shut.
They locked tight.
Yeah, the Earth was completely locked. The lid on the pressure cooker was securely fastened.
Percent.
But this is the part I don't get. The core of the Earth is still, nuclear hot at this point. It's still violently churning out gases. If that intense heat and gas from the core can't escape into the atmosphere anymore, where does it go?
And that right there is the pivotal question driving this entire theory. Because the gas cannot escape, an immense silent pressure begins to build underground.
Just a ticking time bomb.
Exactly. But let's look at the immediate consequence above ground. Because up until the moment those vents sealed, the atmosphere was this toxic, heavy, suffocating soup of volcanic gases.
Basically unlivable.
Right. But once the crust locked, the Earth stopped venting poison.
Oh, so the sky literally clears up.
Yes, the atmosphere began to settle and clear, the air actually became breathable, and sunlight could finally penetrate more effectively.
That's incredible.
And this atmospheric clearing is exactly what allowed complex, multicellular early life to absolutely thrive on the surface.
So the surface becomes this vibrant, flourishing greenhouse. And the plants and early animals are just completely oblivious to the fact that they're living directly on top of a ticking planetary time bomb.
Completely oblivious, yeah.
Yeah.
Which brings us to this massive 475 million year chunk of Earth's history, running from about 541 million years ago right up until 66 million years ago.
The sources call parts of this era the boring billion, right?
They do. And from a traditional geological perspective, boring is honestly a pretty apt description of the surface.
Why is that?
Well, because the Earth was completely encased in that thick, unbroken granite shell, the surface topography was remarkably flat. There were no jagged mountain ranges.
Wait, no Himalayas? No Alps?
None of that. And there were no deep, dark ocean abysses either.
So if the surface is basically flat, where was all the water?
It just pooled in these incredibly vast, shallow swamps and lakes. We were talking about bodies of water that were, at most, maybe 500 meters deep.
Okay, so it was just this globally stable, warm, humid, swampy paradise with a very thick, heavy atmosphere.
Yeah, that's the world.
And this endless flat swamp is the exact habitat where the dinosaurs eventually evolved.
Exactly.
They're just walking around in this incredibly stable greenhouse world. But, I mean, while the dinosaurs are peacefully grazing upstairs, the situation downstairs must be getting pretty catastrophic.
Oh, catastrophic is definitely the right word. Down below, the pressure has absolutely nowhere to go. And over millions of years, the pressure under the sealed granite crust reached a staggering 6,500 bar.
Okay, help me visualize that. What does 6,500 bar actually feel like?
Think about the Mariana Trench. It's the deepest part of our ocean today. If you were at the very bottom of it, the crushing weight of all that water is about 1,000 bar.
Oh my gosh.
So the pressure building up inside the Earth was over 6 times that. It's just an unfathomable amount of outward force.
And the core is still pumping out elemental gases, right? Like hydrogen, carbon, nitrogen, oxygen.
Exactly, it hasn't stopped.
So you have these basic gases trapped under an apple skin crust being subjected to unimaginable pressure. And the sources mention something called Fischer-Tropsch synthesis happening here.
Yes.
I'm definitely going to need to explain it like I'm 5 for that one.
I can certainly do that. So Fischer-Tropsch synthesis is an industrial chemical process we use today to make synthetic fuel.
Okay.
But the Earth was doing it naturally. Under that immense 6,500 bar pressure, those trapped raw gases get squeezed violently upward through these microscopic cracks in the granite.
Just pushing through the tiny flaws in the rock?
Right. And the pressure and heat are so intense that they actually force the carbon and hydrogen atoms to physically bind together into long, complex chains.
Wait, so you're saying the pressure literally squished raw gas into a liquid?
Yes. It literally baked basic gases into complex hydrocarbons.
Hmm.
According to this theory, this process is what created massive deposits of the oil, coal, and natural gas that we mine today.
That is wild. I mean, it completely challenges the textbook idea that all fossil fuels come exclusively from dead, compressed organic matter, you know?
Yeah,
Like ancient fern forests or crushed algae.
it really does.
This theory suggests the dinosaurs were walking on top of a giant, naturally occurring subterranean chemistry lab that was just manufacturing oil from scratch.
It shifts the origin of a massive portion of our planet's fossil fuels from biology directly to intense geological chemistry.
Okay, here's how I picture this entire era. Think of a bottle of sect or, champagne.
Okay, I like where this is going.
You shake it violently, and the carbonation just starts building up inside. For over 400 million years, the inside of the Earth is violently churning. The chemical gases are carbonating. The pressure is mounting to 6,500 bar. And that 60-kilometer granite crust is the cork.
The cork holding it all in.
Yeah.
Right.
It's bulging, it's groaning, it's just waiting for a single microscopic weak spot to give way.
And that is the undeniable law of physics. Eventually, a pressurized bottle has to give. You just cannot infinitely compress expanding gas inside a rigid container.
Right, so if that sect bottle is shaking for nearly 500 million years, how does the cork finally fail?
Well, that brings us to 66 million years ago.
A date most people associate with the sudden extinction of the dinosaurs.
Exactly. According to Meyer's theory, the internal pressure simply exceeded the structural integrity of the solid granite crust. It finally ripped open.
Oh, man.
And it ripped open at its thinnest, weakest point. which was located right around the equator in the exact area where the Pacific Ocean basin sits today.
Okay, but I want to make sure I'm visualizing this correctly. If a planet bursts, it's not like a rubber balloon popping in a split second and leaving nothing behind, right?
No, not at all. It was a sustained, catastrophic expulsion. Imagine a rupture that acts like a gigantic planetary rocket thruster. The depressurization was violently sustained over time.
So it's just spewing everything out.
Highly compressed gases, massive chunks of rock, molten mantle all just blasted outward. And as this incredible internal pressure finally released, the Earth itself physically expanded.
Oh, it puffed up.
The planet increased its overall radius by about 40 kilometers.
Wait, hold on. Stop right there. If you take a sphere encased in 60 kilometers of solid rock, and you suddenly blow it up like a balloon so the radius expands by 40 kilometers.
Yeah.
Solid granite doesn't stretch, it breaks. So wouldn't the ground just shatter into a billion pieces? Like, how did anything survive?
That is a brilliant observation, and it is exactly what happened. The crust didn't stretch, it shattered. That expanding crust cracked into massive fragments.
Wait, are you saying?
Those fragments are what we now call tectonic plates.
No. Oh my gosh, so the Earth cracking like an eggshell is the origin of our tectonic plates.
Precisely. As the planet swelled, the solid plates were pushed apart and the massive gaps between them were quickly filled with magma bleeding up from the mantle.
Wow.
And that magma eventually cooled to form the deep ocean floors we have today.
That completely reframes geology. But let's talk about the material that didn't stay on Earth, the stuff that blasted out of that initial rupture. The sources say the sheer kinetic energy was terrifying.
O is moving at incredible speeds, estimated at 9.5 to 13 kilometers per second. Roughly 2% of the Earth's total mass was violently ejected out into the cosmos.
2%, I mean, that sounds like a small fraction, but on a planetary scale, that is an incomprehensible amount of rock and magma to just lose into the void in a single day.
Yeah.
And the surface impact.
Devastating. The atmospheric displacement, the heat, the shock waves, it effectively sterilized massive portions of the surface.
So this is the mechanism behind the fifth mass extinction.
Yes. The dinosaurs, who were already adapted to a stable, thick atmosphere, they didn't stand a chance against the sudden drop in pressure and the catastrophic environmental collapse.
Now, here is where I really need to push back on the sources, because this next part just sounds impossible to me.
Okay, let's hear it.
We have always been told that a giant asteroid from deep space, the Chicxulub asteroid, slammed into Mexico and killed the dinosaurs.
Right, the classic asteroid theory.
But Meyer's theory says Chicxulub wasn't an asteroid from deep space at all. He claims it was basically friendly fire, like a massive chunk of our own crust that blasted up and then fell back down.
That's the claim, yes.
But gravity doesn't take a vacation. How does a rock blast into space, hover there for thousands of years, and then decide to fall back down?
It's a great question, and it really comes down to orbital mechanics. The rock didn't just hover. When the Earth ruptured, millions of tons of debris were blasted upward. Some of it was moving so fast above that 13 kilometers per second mark that it achieved escape velocity.
So it broke free of Earth gravity entirely and vanished.
Exactly. Got into the solar system.
But the Chicxulub rock didn't make it.
Correct. It had incredible velocity, but just shy of what it needed to escape. So it entered a highly elliptical, chaotic orbit around the Earth. It was circling us.
Oh, wow.
But because it didn't have the momentum to stay in a stable orbit forever, it experienced orbital decay. Over time, perhaps thousands of years, Earth's gravity slowly dragged that massive chunk of granite back down until its orbit decayed completely.
And it slammed catastrophically back into the planet.
Yes.
That is horrifying. We've been blaming random space rocks for decades, when it was actually a jagged piece of our own planet returning to finish the job.
It's quite a twist.
Okay, so the Earth pops, tectonic plates are born, the dinosaurs are wiped out, eventually the dust has to settle. What happened to the material that did manage to achieve a stable orbit?
Out of the 2% of mass that was ejected, about 1.23% of it managed to aggregate in a stable orbit.
So it stayed up there.
Yeah, and over millions of years, gravity pulled that massive debris field together, clumping it into a sphere. And that sphere became our moon.
Which means, wait, if I was standing on Earth 67 million years ago, there was no moon in the night sky.
None at all.
Mind-blowing.
And this brings us back to the tides you mentioned at the beginning of the deep dive. The moon's gravitational pull is what drags our oceans back and forth to create tides, right?
Yeah.
In that pre-small bang world, those shallow, swampy lakes were relatively still. Tides were literally born from the debris of this explosion.
So, the moon is basically a glowing monument to the day the Earth exploded. That handles the tides. But what about the winter chill? Why did the seasons suddenly appear?
This goes back to the physics of the blast itself. The rupture at the Pacific wasn't perfectly symmetrical around the globe.
Right, it ripped open on one side.
Exactly. When that section ripped open and blasted billions of tons of material into space at 13 kilometers per second, it acted like a colossal off-center rocket booster.
Oh, and every action has an equal and opposite reaction.
You got it. That sustained asymmetrical thrust violently shoved the Earth, knocking it off its perfect vertical axis
It tilted the whole planet.
by 23 degrees. Before the small bang, the Earth stood straight up relative to the sun. Every single day was roughly the exact same temperature, depending on your latitude.
So there was no summer, no winter, no spring or fall.
None. That violent 23-degree tilt created the axial tilt necessary for the seasons we experience today.
The chill of winter is literally just a lingering symptom of a 66-million-year-old planetary trauma. That is amazing.
It really changes how you look at a snowy day.
Seriously. But I want to talk about the survivors. We discussed how flat the Earth was before the pop, just those shallow swamps.
Right.
But when the planet expanded and those tectonic plates fractured, it ripped open the incredibly deep ocean trenches we have today.
Yeah, and this creates a fascinating biological pivot.
No.
Think about it. In a shallow, completely stable, brightly lit swamp, evolution is fairly predictable.
Right.
If a marine animal is born with an extreme, bizarre mutation, say the ability to glow in the dark, or a body adapted to withstand immense crushing pressure, it's actually a massive disadvantage in a sunny, shallow swamp.
Right, they stick out. Or they waste energy.
Exactly. Those extreme mutants simply die out. They are outcompeted.
But then the world rips apart, and suddenly there are these terrifying, pitch-black, freezing ocean trenches that are thousands of meters deep.
Yes. The sudden, violent creation of these extreme deep-sea environments provided a massive, completely empty ecological niche.
Oh, I see where this is going.
Those rare, bizarre, mutant animals that would have perished in the old world suddenly found a refuge. They were the only organisms pre-adapted to survive the cold, the dark, and the crushing pressure of the new ocean floors.
Wow.
And over millions of years, they thrived and evolved into the bizarre, bioluminescent deep-sea monsters we see today.
I just love that visual. Like, the terrifying anglerfish with the glowing lure on its head is just an evolutionary weirdo who finally got its own custom-built haunted house to live in.
It is a perfect illustration of how violent geological trauma directly drives biological innovation.
So if this theory explains everything from the moon to the anglerfish, it begs a pretty massive question about the scientific establishment. How did one person working outside traditional academic institutions piece this puzzle together?
Well, it highlights the sheer power of an independent explorer's mindset. Arndt Meyer didn't just wake up one morning and decide to invent a planetary explosion.
You don't just guess that.
He started by looking at the established scientific models and noticing glaring anomalies, things that traditional science couldn't easily or elegantly explain.
Like the moon. I always wondered about the rocks they brought back from the Apollo missions. The sources point out that the isotopic signature of the moon's rocks perfectly matches Earth's rocks. It's like they were cut from the exact same cloth.
Yeah, and traditional models struggle to explain that perfect match without invoking incredibly complex and sometimes highly improbable collision scenarios.
Like an invisible planet hitting us and perfectly blending its material.
Exactly. Meyer also looked closely at the continents. We all learn in school that the continents fit together like puzzle pieces, which they do.
Right, Pangea.
But Meyer noticed a geometric flaw. They have the wrong curvature. They are too curved to fit perfectly on the current size of the Earth.
Oh, I see, because they formed on the smaller pre-explosion Earth.
Yeah.
So when the planet expanded its radius by 40 kilometers, those old, highly curved puzzle pieces didn't lay flat on the new, larger sphere. It's like trying to stretch a small orange peel over a large grapefruit. The edges are going to warp, bend, and leave gaps.
That is a perfect analogy. He took these anomalies, the isotopes, the curvature, the sudden appearance of seasons, and spent over 10,000 hours researching them.
Just grinding through the data.
But what makes this a truly modern story is how he tested his hypotheses. He used an AI named DeepSeek as his primary research partner.
That is so fascinating. How does an AI help you prove the Earth exploded? It's not just like a fancy calculator, is it?
Far from it. DeepSeek acts as a cross-disciplinary synthesizer. Meyer could run his mathematical models through it, ask it to simulate the physics of a 6,500 bar pressure environment, check the chemical viability of massive Fischer-Tropsch reactions,
Just testing everything on the fly.
right, and model orbital mechanics. The AI can instantly pull from geology, chemistry, and physics simultaneously. It acted as a tireless sparring partner to refine the theory.
It is a completely new paradigm for independent research. But here's my major concern with all this. Meyer has this massive, reality-altering theory, and instead of submitting it to traditional scientific journals, he is releasing it under an open-source license on the internet.
It is.
He is entirely bypassing the ivory tower of traditional peer review. Isn't that incredibly dangerous for his credibility? Doesn't he worry the academic world will just ignore him?
He is well aware of the risk of being ignored by the establishment.
Yeah.
But if you read the transcripts of his discussions with the AI, he aligns his journey with historical figures like Darwin and Einstein.
Okay, setting the bar high.
Well, when they first presented their paradigm-shifting ideas, they faced immense pushback and mockery. The scientific establishment is naturally conservative, Its job is to protect established models.
Right, they don't like sudden changes.
Exactly. So Meyer views his open-source approach not as a retreat from science, but as a direct invitation.
An invitation to who, though? If the experts ignore it, who is left to validate it?
The young explorers, the students, the amateur geologists, the data scientists, and the teenagers who are natively comfortable using AI tools.
Ah, that's cool.
He wants fresh, unbiased eyes to look at the world differently. He wants them to take his open-source math, run their own simulations, and test the structural integrity of his claims.
Let the internet try to break his math.
Exactly. He believes that if the physics hold up, the sheer explanatory power of the small bang theory will eventually win out, driven by a new generation of thinkers who aren't restricted by old textbooks.
That is a remarkably inspiring way to view the scientific method. Science isn't just some dusty, closed book sitting on a shelf. It is an active, open-source puzzle that anyone with curiosity and a good internet connection can actually contribute to.
It completely democratizes the pursuit of knowledge.
So let's bring this all back down to earth. Literally. The next time you step outside and you feel that sharp chill of changing season, or you stand on the beach and watch the ocean tide roll in, or you simply look up at the glow of the moon. Remember that according to the Small Bang Theory, you aren't just looking at serene, peaceful nature.
No, you're looking at something much more violent.
You are looking directly at the scars of a singular cataclysmic explosion. You are looking at the planetary shrapnel, the cracked tectonic eggshells, and the cosmic shockwaves that violently ripped our old world apart just to build the incredibly dynamic one you live in right now.
It changes your entire relationship with the physical environment around you. The Earth is a survivor.
It really is. And, I want to leave you with one final, slightly terrifying thought from the sources to mull over tonight.
Oh, the Mars and Venus connection.
Yeah. Meyer's research suggests that our Earth isn't totally unique in this explosive process. When you look at Mars and Venus, they both feature extreme axial tilts and massive, strange geological scars that traditional science really struggles to explain.
Right. The theory suggests they likely had their own small bangs in the distant past.
Which implies a much larger rule, right? That rocky planets are essentially just cosmic pressure cookers moving through linear, explosive phases of evolution.
Yeah, it's just a phase they go through.
Exactly. Which leaves you with this chilling question. If this is simply the natural life cycle of a rocky planet in our universe, is the immense pressure inside our Earth slowly building up once again, deep beneath our feet, quietly preparing for the next explosive phase of planetary evolution?
Well, that is a thought that will certainly keep you up at night just listening for the rumble.
On that explosive note, thank you for joining us on this deep dive into the source material. Keep exploring, keep questioning the world around you, and keep looking up at the moon.